Hi class, this video is going to help with 8.2 and I just have a couple examples I'm going to give you so that I can show you how to do these in Statcrunch. And then there's lots more examples in the lecture section. So let me go ahead and share my screen here. And I want to remind you of a couple things from 8.1, and that is if our P is low, the null must go, and if P is high, then we fail to reject, right? So this one is like we have enough evidence for that alternative hypothesis to be correct, and the second one is we have enough evidence to keep the original null. Okay, so let's look at a couple examples. I liked this one because it had to do about McDonald's. McDonald's had 33 orders that weren't accurate among 362 orders observed. Use the 0.05 significance level to test the claim that inaccurate orders is equal to 10%. Does the accuracy rate appear to be acceptable? Okay, so we got to think about, first of all, were we given, well, this whole section doesn't give us a mean, but we need to think of this way. Are we given a proportion or are we given a mean value? We're given a proportion because we're given 33 out of so many. Okay, and then we have to talk about what is the claim. The claim is 10%. So over here on the right corner here, I have to think about my null is always equal to whatever percent, which was 10% on this one. And for this one, our alternative is just not equal to 10%. We weren't given less than or greater than. We weren't left or right-tailed. So we're going to have our two-tailed. Okay, so this is our first thing we want to write down. And then we're going to go into Statcrunch and find the rest of this information here. So let me move over Statcrunch. Boop, boop, boop. Okay, so we know we have our proportion, so we're going to go to that proportion section again. One sample, and we don't have data. We have a summary. And we were given 33 inaccurate orders out of 362. And then what was this value here? It was 0.1 for 10% and not equal. So we push compute. And what do we have here? Well, we have that Z statistic that they might ask you for. And the most important part is that P value, the probability. Okay, so again, this was a proportion. So I did stat proportion, one sample, because we just have one sample with summary. So that gave us this Z statistic here, and that gave us this P value here. So that P I can already look at, it's like 57%. It's super high. So clearly, if it's high, we're going to fail to reject, right? Because our P value is definitely bigger than the 0.05 given as our significant level. So we fail to reject the null hypothesis. Great. We should be able to do that. But what the heck does that mean? What does it mean in terms of McDonald's when we say we fail to reject? It means there is not significant evidence to warrant rejection of the claim that the rate of inaccurate orders is equal to 10%. Basically, we're saying we're about 10%. That's where we're at. So 10% are inaccurate. That really seems kind of high to me. I don't know, just saying. Okay, so my next example, or my last example, I'm only going to do two. There was this poll given, and it was asked if you were in favor or opposed to using tax dollars to fund stem cell research. Big controversy, right? Of those polled, 481 were in favor and 401 were opposed, and 120 were unsure. What we're going to do is we're going to exclude these unsure, okay? And we're going to have a significant level of 0.01. And we're going to say this politician claims that it's like flipping a coin. It's 50% are in favor. Well, what do we think about his claim? His claim is 50% are in favor. Okay, couple things I want you to realize. We weren't given a certain number out of our total. We were given how many are in favor, how many are opposed. So you might have to add some numbers together to get the total, or to calculate out a percent in some cases. So for this one, 481 and 401 we're going to use, and we're going to ignore the 120. So we would have to add those together to get that total. So here's what I'm thinking. Okay, so I'm saying there are 481 out of 882. Okay, and so we're going to say our null is equal to that 0.5. That's the claim. We're equal to 0.5 and not equal to 0.5. We didn't have greater than or less than, just not equal again on this one. And so let's go into Statcrunch and see if we can get this Z and this P that I have here. So this time we're going to go into our stat again and our proportion, because we're still in the proportion. And we said there were 481 out of 882 when we added the two together. And what we were at 0.5 and not equal to halfway. So here's these values. So here's our Z statistic and our P value. Now I can look at that P and go, oh wow, that P is pretty low, 0.0071. And in the problem, we were given a significant level of 0.01. That refers to 99% accuracy. So we can see that that number is definitely small. So we're going to reject the null. He is not saying something true. It's not 50%. We have enough evidence to claim that, to reject this null, that it's not equal to the 50%. So we would say that statistically, there is significant evidence to reject the claim that the proportion of those in favor is equal to 50%. This result really suggests the politician is wrong. Okay, so this is kind of what you're doing in all of 8.2. You're using all just that proportion section in Statcrunch. All right, so, and then you have to come up with these different parts. There's a lot more examples if you need them in the book or in the lecture section.